Hello everyone, and welcome back to the Fluctus Channel.
3, 2, 1, ignition.
Fighter jets are fast-flying machines, mainly designed to travel at high speeds. Some advanced fighter jets can pierce the skies up to Mach 2, which is 2 times the speed of sound. But even the quickest jets are not too fast for a missile. Missiles are built based on a golden rule, which is that they should be at least 3 times faster than whatever they're aiming at, so they can easily catch up to and take down these speedy aircraft.
Guam Center, Panther 3-1.
They're not just for attacking jets, though. Missiles are versatile and can be used for all sorts of things, like hitting far-off ground targets or stopping other missiles. These powerful weapons can be used by an aircraft, always ready to go if needed, to keep the sky safe and secure. Let's understand how a missile is built and its functionality. A missile consists mainly of 3 compartments. First, the guidance, targeting, and flight systems. These are the missile's navigation tools. They help it figure out where to go and keep it on the right path, using GPS and sensors that lock onto the target. Next is the propulsion system. This is the engine of the missile, mainly its powertrain. It's what makes the missile speed through the air. This system includes the engine and the fuel that powers it. Lastly, the warhead. This is the main compartment of the missile, the part that does the damage. It's designed to create a big impact on whatever it's striking, using explosives that are meant to be super effective when they reach the target. Missiles come in various types, each designed for specific tasks. These include intercontinental ballistic missiles, air-to-surface missiles, surface-to-surface missiles, surface-to-air missiles, anti-submarine warfare missiles, air-to-air missiles, and submarine-launched missiles. One of the most well-known types is the Intercontinental Ballistic Missile, or ICBM. These are some of the most powerful weapons in the world.
Item 135, launcher closure.
They can travel over 3,500 miles, allowing them to reach from one continent to another. The concept of ICBMs originated during World War II with the development of the German V-2 rocket. As technology progressed, especially during the Cold War, the United States and the Soviet Union developed these missiles primarily to carry nuclear warheads over vast distances. The idea was to deter each other from a nuclear attack with the threat of a retaliatory strike. ICBMs continue to play a vital role in the defense strategies of several countries today, serving as a cornerstone of national security. Since the early 1960s, the U.S. has been operating underground missile silos to store and launch ICBMs. A missile silo is basically a vertical underground chamber covered by what looks like a giant concrete slab on the surface. So, what's it really like inside one of these missile silos? Let's take a closer look together. The United States has around 450 operational ICBMs ready to fire from these underground facilities. Before any missile is launched, the launch crew performs a pre-launch check to make sure the missile and all its systems are good to go. Workers enter the silo via an elevator and carefully inspect the missile's body. There's also a passage leading to the launcher equipment room, where the launch crew checks the guidance system, propulsion, and safety mechanisms. Once everything is confirmed to be in working order, the launch crew gets the final go-ahead to launch. The launch process starts with a countdown, and for safety, all personnel must leave the area near the silo.
3,
The ICBM is then launched from its underground home. And the launch crew continues to monitor and adjust its trajectory until it reaches its target.
All right, hands on keys.
While every missile silo has a built-in launch control center, however, in the case of ICBMs like Minuteman III, the control center is not situated at the launch silo. Instead, 2 officers are stationed in an underground control center, connected via 10 different silos, typically known as a flight. To protect the flight from hostile attacks, each facility is situated at least 10 to 20 miles away from each other. The launch control centers or launch crews stay active 24/7 and maintain reliable communication with the President and Secretary of Defense. While ICBMs are typically launched from underground silos, they can also be deployed from the air. For this purpose, the military deploys a specialized aircraft developed by Boeing, the E-6 Mercury. Originally known as Hermes, this aircraft serves as an airborne command post and communications relay.
This launch is designed to show that our weapon system is capable, reliable, and accurate. And it also is a message to our adversaries that we possess this very capable nuclear deterrent and that it does work.
Based on the Boeing 707-300, the E-6 Mercury started its service with the United States Navy in July 1989, replacing the EC-130Q. This aircraft has since been upgraded to the E-6B model, which was introduced in October 1998. The E-6B is particularly significant because it can remotely control Minuteman ICBMs using the Airborne Launch Control System. While intercontinental ballistic missiles, ICBMs, are built for delivering large payloads over vast distances, smaller, more precise attacks are carried out using specialized missiles from advanced fighter jets like the F-16, F-22 Raptor, and F-35. These jets use 2 main types of missiles, air-to-air and air-to-surface. For air-to-air combat, where the goal is to take down enemy aircraft, pilots rely on missiles like the AIM-9X Sidewinder, which is great for locking onto heat sources like jet engines. There's also the AIM-120 AMRAAM, a radar-guided missile that can hit targets far away. The AARGM-158 JASSM offers stealth features that help it avoid detection and can strike targets far beyond enemy lines. The AARGM-179 JAGM can hit both moving and stationary targets thanks to its dual guidance system. Apart from these missiles, nuclear missiles also play a crucial role in modern warfare. Advanced aircraft like F-35, F-22, and F-16 can deliver a nuclear payload as per the requirements of the mission. Cheyenne Mountain was excavated by the Army Corps of Engineers to construct the NORAD Combat Operations Center and became fully operational on the 20th of April, 1966. Over time, the Cheyenne Mountain Complex housed elements of the U.S. Strategic Command, U.S. Air Force Space Command, and U.S. Northern Command. The entryway into the Cheyenne Mountain Complex features the insignia of 4 tenants, including NORAD, U.S. Northern Command, Air Force Space Command, and U.S. Strategic Command. There are several buildings inside the Cheyenne Mountain Complex, each 3 stories high. The main building features various amenities for the personnel, such as a medical facility, a store, and a cafeteria. In addition, there are fitness centers both inside and outside the mountain. Inside the facility, there are a large number of cots for most of the personnel, including exceptional suites for high-ranking officers. The Cheyenne Mountain Complex was designed to protect against a nuclear blast or an earthquake. Therefore, more than 1,000 giant springs are placed under 15 buildings of the complex, allowing the structures to shift up to 1 full inch in any direction. These springs are expected to protect the building and the personnel inside. The Cheyenne Mountain Complex is now managed by Air Force Space Command and hosts the activities of several tenant units. As of 2023, it is an alternate command center for NORAD and U.S. NORTHCOM and is used for crew training. All the original functions of the complex were removed to Peterson Air Force Base, located in Colorado Springs. Now, NORAD and U.S. NORTHCOM use less than 30% of the floor space within the Cheyenne Mountain Complex and comprise only 5% of the daily population at the facility. Previously, this facility was a joint operations center for NORAD and U.S. NORTHCOM. Several other units, along with U.S. NORTHCOM, supported the NORAD missions. The Cheyenne Complex was a defense hub of the United States and supported aerospace warning and control missions. It was also capable of warning against ballistic missile or air attacks against North America. From high-speed fighter missiles to underground silos and command centers like Cheyenne Mountain, these systems illustrate how technology, strategy, and deterrence intertwine to secure nations, shaping both global balance and frontline operations. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.